Thank you. Thank you.
That's a lag. That is your
Thank you. I also want to put you guys in the know real quick. I don't know if you've seen the Army of Ants coming through the room. There's a reason for that.
Food.
Exactly. So, please watch what you're leaving behind. I don't like, pick up your stuff because otherwise you're going to get stunned later on. Alright. I hope you do not. It hurts. Cool. So this week we're starting with functions. We're starting the new unit. It's all about functions. I think you guys have seen functions before. Used nothing to grunt about. It's not a big deal. But just so you know, for those of you that weren't here, your cell phones are going to be out. They're not going to be in your ears, so remove the headphones, and they are turned upside down at the top of your desk. Thank you. Your headphones. That's enough. Thank you. So, functions as a result of calculus. Well, you know what? You're going to have to get used to the idea because that's where you guys are headed. As you guys know, math is all about building. And right now, you guys have done, what was it, geometry? And then you guys came back to algebra. I think that's where you guys are going to be for a while. The next course up is pretty much pre-calculus. You want to start getting into the notion that that's where you're headed for next year. We can call it whatever you want to call it, but that's what it is. You can call it Algebra 3, 5 trig, whatever it is. It's still pre-calculus. So as a function of calculus. The term function was introduced by Gottfried Leibniz. I love his hairdo. I wish I had that. I could do all kinds of stuff with that. Can't do much with mine. But the idea of that came out with some very important things that they were trying to figure out. I think that we've all talked about, have done the problem with the average rate of change, right? Oh, you got a car or a train that's driving at 45 miles per hour. How far will they get in an hour?
What?
Okay, there's a train driving, or what does a train do? Do you say driving? Tugging? Whatever it does. Traveling. There's a train traveling at 45 miles an hour. How far will he get in an hour? 45 miles, hopefully, right? Because the math is supposed to work that way. So what that really is, and when we're talking about this, calculus, average rate of change versus instant rate of change, is that I know that before, when we're working with average rate of change, you got a starting point, don't you? And then you also have an ending point. And there's all kinds of stuff that happens in the middle, isn't there? Is this really how we travel? Is it always linear? Constant speed? No. We know that when you're on the road, you got to be slowing down, you got to speed up, slow down. So it's really this crazy curve, regardless of where you travel. But overall, we've always been interested simply, thank you for closing your laptops, simply talking about the average rate of change. You know, from point A to point B, how far did you travel? And how did we usually find that? Yeah, we had a specific formula, right? For average rate of change. I don't think you guys have called it that, but you guys have heard me use it already. What do you got, James?
Slope intercept.
We use some of the slope intercept stuff, but specifically the slope itself. When you're calculating slope, you're calculating the average rate of change. Robert, thank you for closing your laptop. So, slope, I think you guys have calculated it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? Questions on that? No, that's average rate of change. If you didn't know that, put that in your notes, write it down. And we used to call this M, right? Here I want to add a curve to this. X, where's my square? X squared. Boom, there it is. Can you guys see that okay? see here, and I want to. I guess that won't work. Okay, so let me just go ahead and draw it. So everyone's okay with average rate of change? Any questions? Average rate of change? You've been doing it forever, right? Kind of sick of it? Well, the question happens here. As they were doing average rate of change, they said, you know what? I want to know what happens, though, if I put these closer and closer together. Does the average rate of change become more accurate within a specific time frame? Yeah. You would assume so, right? That it becomes much more accurate. And there became a need to know, well, what happened not in the whole trip, but in this specific part of the trip. Kind of like when what was it, that rocket that blew up into space and killed all kinds of astronauts. Okay, we weren't interested in the whole thing, right? Well, it looked like the whole, on average, they were traveling the right time. Okay, but that wasn't a big deal. That didn't really matter too much. What happened when it started failing from here to here? So take a look at that. And then even more important is like, well, that's not very informative. The question is, what happens when we do this? I just put 2 points on top of each other. What do you think that's asking? Is that still the average rate of change? I'm saying from right now to whenever I said right now. It's not average anymore. Okay? What that is saying is, what was the average rate of change at this specific point in time? It is called instant rate of change. Okay? And what we found was, let's give these some numbers there. Let's give these some values. Someone make up a coordinate for me, please. 4, 4. I like that. That's not bad. 4, 4, which means that the other point is also 4, 4, right? So here's what happens as they were trying to calculate instant rate of change. Let me change this real quick because I don't like that. So as mathematicians saying, all right, well, let's find the instant rate of change. I've got 2 coordinates. They both happen to have 4, 4. We'll call this the first coordinate. We'll call this one the second coordinate. So I'd have to go 4 minus the other point, which is 4, right, on the y's. And then in the denominator, I'm going to have to go 4 minus the other point, which happens to also be 4. And what I got was 0 over 0, which gave me a rate of change of 0. No, that's not true. If you're driving down I-10, actually moving, and you say, how fast are you going? You don't say you're going 0 miles an hour. Especially if you're driving at 75, right, or 80. Well, maybe it was a coincidence because we chose 4, 4, right? Maybe that's the way the numbers work, and that's not what was supposed to happen. So let's make these a little bit more different. Someone give me 2 very different numbers for the coordinates.
7, 3.
7, 3. So if I did 7, 3, that means that the other coordinate is also 7, 3. And if I take a look at that, it's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So here's my second y, there's a 3. There's my first y, there's a 3. So 3 minus 3 gives me 0. And then I've got 7 minus 7. I get 0 again. And of course, we know that that's not true, and the math has failed us. Yeah, well, no, math doesn't not fail us. Well, the idea is that, whoa. Like I said, something needed to be changed. Something needed to be changed. And of course, it happened with Leibniz when we started introducing this idea of instant rate of change and when talking about functions. It was actually a pretty simple fix, which was really interesting. And people started saying, well, you know what? And there was arguments for it and arguments against it. Let me go ahead and add a picture here. I think on the calculator I drew a parabola, didn't I? It looks something like this.
Yeah.
And obviously that's a parabola that's curved. But the question kind of came up, or I guess you could argue that if you're looking for average rate of change, that means that there's a line that kind of goes through there, isn't there? Well, obviously if you're looking at one specific point, there's no slope, is there? And isn't that what you're measuring? Slope m?
Yeah.
So, funny business. So obviously Leibniz, it makes sense that you get 0 all the time. There's no lines going through there. Right? Well, there was a graduation from that point. If we did take a look at the y sub 2 minus y sub 1 over x sub 2 minus, well, that should be x sub 1. it was a simple change. Something was introduced, this idea of functions. Okay? And functions were something special. Okay, there was a specific rule that they had to follow, and I'm going to tell you what that rule is. Guys, you're not going to like it. Too bad. That's how a lot of people learned it when I've taught it. And they say, oh, that kind of makes sense. I still don't like it, but it'll work. Okay? But anyways, it was something very, very, a small change that was done to this, and it made the whole thing work, which is really, really interesting. We're not going to worry about that right now. We are going to go ahead and jump into the definition of a function. I thought I copied that over. There it is. So this definition of a function, this is what your book is calling it for now. And it's okay, it'll work. It's saying it's a pairing of items. It's a pairing of items from two sets of a pairing of items from two sets is special if, and here's the main thing, if one item from one set of pairs with exactly one item from the second set. So if there's one item in the first set, it's paired with exactly one item from the second set. And those always mess me up. They didn't make too much sense. They didn't make too much sense. Now these, we've seen them over and over and over. And sometimes they still just don't make sense, right? So let's do it like this. Oh, sorry, do you guys still need that slide? Don't worry about the pictures. If you want to write down this. Okay. There it is. Welcome back. We didn't lose much. Are we good with this slide? Can we move on? We close it now? Yeah? All right, cool. We know that there's these two types of data. We've been calling them X and Y for a long time. But there's other names, right? There's the, what is it? The input, output. There's the independent and dependent. There is the, I forgot what we call them, statistics. Explanatory and response. One explains what's happening to the other one. So you got explanatory response. So there's all kinds of names for those. Right now I'm going to give you, not a real name, but kind of a name to kind of give you an idea of what we're talking about here. So that this idea of what a function is makes sense to you. And think about X as being boys.
Oh, I thought it said raise.
Yeah, raise. No, boys. Which means Y would be girls. Okay? Now here's the rule. I've got a bunch of guys over here, but I don't want to put them on blast, so I'm not going to use their name. I'm going to label them. These guys are called guy number 1, 2, 3, 4, and 5. Okay? And over on the other side, on the girls' side, I'm going to do the same thing. I've got girl number 1, 2, 3, 4, and 5. Okay? And I think you guys have seen those are just numbers, right? Just like they are in our data sets. Here's the rule. Are you ready for it? There's one rule. Remember right here it said items from one, it says pairing of items from two are special if this happens. And here's what needs to happen. Da-da-da. Every guy or every boy can only be with one girl. That's the only rule. In order for this to, and I love this whole thing, because we call functions relations, or relations, right? So in order for a relation to function, the only rule that must be followed is that every guy can only have one girl. So what's the rule?
Every guy can only have one girl.
What's the rule?
Every guy can only have one girl.
What's the rule? Meerhofer? That sounds good. Thank you. So every guy can only have one girl. That's it. We're done. That make sense? Okay, some guys be tripping. Because there's no rules about girls, is there? Can a girl be with more than one guy?
Yes.
Yes, that is okay. It is still fun. Now you guys are in order for a relation to function, every guy can only be with one girl. Okay? Later on, guys, later on, when you start doing some pre-calculus, we'll have what's called a one-to-one relationship. One-to-one. Those are the monogamous ones, where one guy, one girl, one guy. But we're not there. Right now, the only rule in order for functions, or for relations to function, is that every guy can only be with one girl. Does that make sense? So, if I make this pairing, if I said this guy is with girl number 2, this one's here, they hooked up, and they're together, does this relationship work? Does it function? You would say, yeah. Yes. Is every guy with exactly one girl?
Yes.
Yeah, it is. Any questions about the rule? Only one. There can only be one. Let's move on. All right, cool. So let's represent some relations here. Let's take a look at it in the form of the table here. You guys have seen that, right? 1, 2, 3, 4, 5. Take a look at this pairing. Take a look at this pairing. Is this a function? Is it going to function? Is it?
Yes.
Why? You said yes, Infinity. Why?
Just by looking at it, it's just like you're adding 1 to each one of the fields, like 1 plus 1, 2, 2 plus 1, 3, and so on.
So what if this was... How about now? Is this relation going to function? You guys thinking way too much about it. What was the rule I gave you?
One guy, one girl.
One guy, one girl. Is this data set following the rule?
Yes.
It don't matter what the numbers are. That's what I'm saying. Don't make it harder than it is. I gave you one rule. Is every guy with one girl?
Yes.
Yeah.
Therefore, is this relation a function?
Yes.
Yeah, that's simple. No need to complicate things. Math don't like hard. Right? Math don't like hard. We don't. All right, let me change this up a little bit. How about now?
No.
Is this relation going to function?
No.
I heard no, I heard yes.
No.
Raise your hand if you say no.
Oh wait,
Alicia, tell us why it ain't going to work.
because there's 2 guys with the same girl.
There's 2 guys with the same girl. Which 2 guys are with the same girl?
3 and 4.
Let me ask you this question. Who's number 3 with?
6.
Anybody else?
No.
Does that follow the rules?
Yeah.
Yes.
Is guy number 4 with a different, with how many girls?
One.
No.
1 girl.
So wait, yeah.
Is that breaking the rule?
No.
So, let me ask again. Does this relation function?
Yes.
T. Willie,
If then 6.
is this relationship function? Hold on real quick. Yes, why?
Because it agrees with, because the Y's can have as many people they want, I guess.
The Y's can have as many people as they want. Because Y's are what?
Oh.
Girls.
Watch those words. Your question?
Maybe because if it was 3, like, if there was another X in 3.
There's another what?
If 4 was a 3, it wouldn't be a function.
Right, but is this a function?
Yes.
This is a function. This is totally okay. Guys, please watch those words. I know you're going to want to use them a lot. Do not. Okay, it's just a fun way for it to make sense. But I could teach it the hard way too. And it'll still work just as well. Math don't like hard. Exactly. Me no like you hard. So, let's go here. Let's get rid of some of these numbers. Let's change this data set again. You guys ready?
No.
I'm not even done. Why are you judging?
There's 2 more.
Is this relation going to function?
Yeah.
Robert,
Yeah.
is it going to function or not? Yeah, why?
No, the ones are still with 2.
Girls, would you mind if they took you on a second date?
What?
Would you mind if your guy took you on a second date?
Yeah.
You would?
Oh wait, no, I won't.
I wouldn't mind. Is he cheating? No, he's with girl number 2. Maybe 2 times, maybe 3 times, but that's still not breaking the rule, is it? Guy number 1 is still faithful to girl number 2. Now, if this was going on, would that be okay?
No.
Not a function. Not a function. How about this? Function or not a function?
Function.
Function.
4 is the only loyal one.
4 is the only loyal one.
What's that?
No. Are you seeing the difference?
Yeah.
Good. Now, someone last year brought this up. They said, you know what, Mr. Munoz, when I'm trying to figure this out, I just take a look at the X's. And if the guys show up more than one time, I take a look who they're with. And if that person is the same person, then we're good to go. And if they're not, then I say not a function. And that makes sense. Because do we have to worry about the girls?
What do you mean?
So here's what they said. They take a look at this here. So take a look at the top. Oh, one shows up more than one time. So who is one with? You're with 3 and 2. Is that the same person? No, that's girl number 3. That's girl number 2. So that's 2 different people. Therefore, not a function. Make sense? Now, this is one way that you see the data. Sometimes they'll give you data like this. What do we call that? It's called a graph. We don't know what that is. I don't know what that is. But it's a graph of something. And they're going to say, is that a function or not?
Yeah.
Okay? Now, some of you guys know because you use something called the...
Yes.
The what? It looks like it?
Oh my God, bro.
Yeah, the vertical line test.
Thank you. Thank you. You said vertical line test. Some people say... Thank you. Some people say, well, you know what? This passes a vertical line test. That means that I can draw this line anywhere I want, and it won't cross the line more than once. Well, what you're doing is the same test. Here lives an X, right? And he has, on the y-axis, there's only one girl that he's connected with. Okay, so it's the same thing. Now, if you want to just do the vertical line test, that's fine. But all you're checking is, does this X have more than one Y? And that's all you're doing. So, if you get something like this, and you've got that, the question is this a function? This is not a function. Because if I take a look at this guy right here, he got a girl up here on the north side and the south side. Make sure you keep them opposite sides of the tracks, right? So that's not going to work. So vertical line test, if that works for you, cool. Same thing. But sometimes when you're looking at data, it's easier to see it a different way, isn't it? Questions on functions or not? Anybody? All right, let's take a look at these pairings up here. Can you guys see those okay? Make it a little bit bigger. Are these pairings are they a function? Way too loud up here. They are a function?
Yeah.
Yeah? How do you know?
But they don't mix.
Who is they?
The girl.
All the x's. What are the x's? The first number, so 0, 4, 8, 12, 16. Those are all the guys? Okay. You also need to know one of the names that they have. Starts with it. Never mind, I'm not going to say what it starts with. But they are called the domain. They are called the domain. All of the x values are called the domain, which means that all the y values are called the range. And they'll ask you to do that. Identify them. So just like we did here, these are all the domain. And I'm not writing all those other numbers because that's big numbers. But you see them, right? And you put all the y's together and you say these are the range. Domain and range. Questions on that? Can you guys grab domain range from here then? Can you grab domain range? Can you grab domain range from here? Robert? Go ahead and turn to your neighbors. See if you can figure out domain range from here.
I'm trying to just figure out Tristan, don't. You retarded. You're gonna mess up your eyesight. You're gonna say what's wrong with you. Mister? I don't think we can figure it out.
Oh, this is not going to take too long.
Actually, I think we are.
Okay. Here's the other way to do it too.
My eyes are hurting. I'm not going to anymore.
You made eye contact.
I'm looking what you're doing.
Thank you. Thank you. If I give you a picture like this, can you tell me what the domain and range are?
Yeah.
Devin?
Yeah.
Go ahead. You volunteered. Go for it. What is it?
The range is negative, negative 2 to 9.
The domain
Or yeah, the domain
is from
negative 2.
this one?
Yeah.
No. From -2 to
9.
9. Devin, how do you know that? For those of us that can't figure that out.
Because it's blocked off. So the dot.
Okay. We said that x's had a name, and that was domain, right? So if I ask you for domain, then what am I asking you for? I'm asking you for the x's. So we know that this has two axes on there. One is the x-axis, the other is the y-axis. So if I'm looking for the x values, then what I'm after really, that was a quick pee, bro.
He just walked straight outside.
Okay, don't do that again.
Your eyes hurt, huh?
So,
They don't do that.
so those are the x values that I was after. Okay? That means that if I look at this picture, where did it start? -2. Is there any breaks in this? There isn't. So that means that this function or this graph takes on all of the values, Alexa, from -3 Are we good? Takes on from -3 all the way to 9. And that's why that's the domain. And if we're looking at range, then what we're really looking for is the y values. Okay? So we're looking at all the values that go from, I'll use another color. Devin, thank you. From here to there. So what are the values one more time, Dev? Sorry, I was thanking you in advance.
-2 and 9.
Yeah, we're going from -2 to 9.
Oh, offset 2.
-2 all the way up to
3.
3. Okay, so there's my range. It goes from -2, that's my lowest point, and it's going all the way up to a +3. So there's your domain, there's your range. We'll do more of those later on.
You're welcome, Mr. Munoz.
Is this a function?
Yeah.
How do you know?
Because it's 1 with 1.
Is it?
Yeah.
All I have to do is make sure that there's how many aerials coming out of these numbers?
1.
Just one. If there was more than one,
It's not a function.
just make sure it's the same number on this side. Because if it's not the same number, then yeah, so you have to be careful. Don't just make that quick assumption,
Even if
okay?
they don't even have the same pattern, it's still considered a function.
Okay, so.
Is every x with just one y?
Yes.
That's all that matters.
I don't know very much.
What was the one rule I gave you?
Every X.
Every guy
has
has.
one girl.
Does anything else matter?
No.
Don't make this hard for yourself. Okay? Don't make it hard for you. Just pick up what I'm asking you to do, and that's going to be good. What rule can we use for this? You said it earlier. Vertical line test. Would this be a function? Would this be a function?
No.
Yeah. Yeah. How about this A? Obviously A is not right. But C, a lot of people do have trouble with that. Doesn't matter if it's a bunch of scattered points.
Maybe you should look down all these forms.
Which one is a vertical line test?
The points are not straight. Ah, look at that. You're right. Watch out.
Ooh,
Yeah,
Robert's
you're
actually
smart.
smart.
No. Robert is correct. Sorry, no, not that he's not smart.
He said
I just thought about what you said.
He said Robert's not.
I was saying if he's paying attention is what I wanted to say. Thank you, Robert. I didn't even catch that. So, those 2 points make it not a function, right? So, not a function, function, not a function. Okay. Using function notation. Using function notation. Including myself, I've always had questions about, well, what is the difference between a function and an equation, right? Because we've seen equations a lot of times. This one is one of the most popular ones that I know. Y equals mx plus b. Okay? I can write that as a function if I wanted to. That becomes f of x equals mx plus b. So they're equivalent pretty much, except one is written in equation notation, the other one's done in function notation. And the thing about function notation is that, from what I've noticed, is typically they're already solved for a specific variable. In this case, y. All that happens is y becomes this thing called f of x. And that's important to know because I can name the function changing that letter f. I can call it p of x or I can call it p of n because simply what's inside is the independent variable. Okay? Now, a lot of functions can be expressed as equations, but not all equations can be expressed as functions. Here's one for example. Okay? X squared plus y squared equals r squared. Anybody recognize that? That's the equation of a circle. Okay? If I did want to write that as a function, I'd have to write two functions. So, function notation is simply that, where this becomes f of something. So let's try writing those. Since you guys can't probably read that very well in the back, I'll read it to you. Ticket price. Tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. So first what we need to do is we need to create a function. We're writing a function for the cost of what? Cost of tickets. So I've rechanged all of it from f of x to read c of t. C is just telling me some name for it. It doesn't matter what that name is. It's totally up to you what you want to call it. But usually they label it after what you're looking for, which is the y part of it. Remember how before we said, oh, you can give y an actual context and say that we're looking for the number of snow cones or how many calories it has. We can do the same thing here with the number of for the cost of tickets, okay? That was awkward walk to the bathroom. But anyways, we have some information from here. We know that we're going to be charged a basic fee. What is that basic fee? Well, that's the cost for each ticket. But there's the $2.50. Does that change?
No.
It doesn't. It's regardless, right? So that's going to be our constant value. So this means that this is always going to equal 250 pennies. That's what I meant to say. $2.50 plus however many tickets I get. So here's the cost, 250 plus $35 multiplied by the number of tickets that I do purchase. So here's my function. That could have been written as an equation if I wanted to. But what we're trying to do right now is we're trying to ease you way into the world of functions so that that makes sense to you, okay? So questions on my function up there? Cool. if I wanted to do this next part, which is to evaluate for 4 tickets, then this becomes C of something. What does T become? It becomes 4. So every time where T used to be, what will it become? What happened to T? Got switched for 4, so what should happen to my T over here? Switch for 4. And then I can go about simplifying that if I want to. Actually, I do need to because they said evaluate it. So C of 4 is equal to, now notice they used the word evaluate. Did they say solve it?
No.
Because am I solving it? No. I know the value of x that I want. I'm simply plugging it in. And what I'm doing is simplifying the right side of the equation. So in this case, I've got 250 plus, what is that, 140? 140. Therefore, C of 4 is 142.50. So if I did purchase 4 tickets, then I'd have to pay that much money. Now, what's really nice about function notation is that I know everything I need to know if I want to graph this point. I know the value of x, and I know the value of the function itself. So I can make a coordinate right out of that. If I did want to write it as a coordinate, what would it look like? 4, comma, yeah, 142.50. Okay, questions on that? All right. Function or not a function?
Nah.
Why not?
3 is -5.
3 is with what?
2 and 6.
Yeah, with go 2 and with 6. So that is not a function. But we can still talk about the domain. Can someone identify the domain? Mr. Willis? Mr. Willis? Mr. Williams?
-5.4.
The domain. Write these in your notes. What else we got? Were there any more? You guys think of any others? Names?
Rise over run doesn't count, huh? It's just like
I guess you could say that this is the. Oops. Wrist. It's all in the wrist. So I guess you could kind of call those rise run. That's a good one. I never thought about that one. The rise and the run. Because rise is y, right up and down, and you run across on the x-axis. That's not bad. Put those in your notes. Commit them to memory. I'm not saying they might be on a test, but they might be on a test.
Can I go take a look at the beautiful sun?
No. Why are you thinking so much? No, you didn't.
I looked at it too. Do you think I'm gonna die?
Yeah, it is. It's starting at 9:14.
Mr. Gardner said that we can't really see it.
We're not going to see it. It's not going to happen here.
Like, I just asked him right now. He was out there. He said that, like, we could barely see anything.
People only look at it because they're told not to.
I saw a little. I looked in the sky earlier and I saw a little orange thing. What the fuck? Oh.
Oh my god.
You just made my day today. Are we done with this one?
No.
That is very appropriate time. Good? Oh, guess what? That makes us done. Any questions on any part of that? All right.